Today's lesson is all about operations with rational numbers, but dealing with real world situations. So, hopefully, lessons that you've done before this is about adding, subtracting, multiplying, and dividing rational numbers fluently. So, using just like the algorithm. And now we're going to be kind of applying those rules to real world situations. So, we're going to be looking at story problems and we're going to be writing and solving real world problems using the four major operations of addition, subtraction, multiplication, and division of rational numbers, which means that includes all the positive and negative integers, fractions, and decimals. So before we dive into some examples, take a minute to kind of think about when you read a story problem, what are some of the key words or topics that are associated with each of the operations below? So take a minute to fill in this chart, pause the video, and then I'm gonna reveal some words that you might associate with each of those operations. So here are some of the words on the screen. Again, feel free to pause and kind of record some of the words. I feel like for adding, you're going to see a lot of real world problems about depositing money, something increasing by, being combined together. Subtraction, a lot of times you're going to see things being decreased. If you're talking about money, seeing things being withdrawn, a loss of something. Um, Multiplication, a lot of times you're going to see like uh, thinking about having groups of or for every or for each. Dividing also can use the word each, so just be careful when you're reading it. We'll look at some examples. A lot of things will actually say divided into or like sharing equally. Average is always a big one for division as well. So just keeping those words in mind when you're thinking about what are some keywords that are going to tell me what operation am I going to use in this problem. And then besides the four operations, we also have to decide what are some keywords that are going to help us decide if our numbers are going to be positive or if they're going to be negative. And so this is where, positive numbers usually mean like you're going to increase, have a gain above zero, and then you're going to have your negative numbers that usually mean like a decrease, a loss, a drop, or like below zero. Okay. And then lastly, after solving a real world situation, always think about, does my answer make sense? There's so many times when, I ask my students, like, does that make sense? And they kind of just take a minute to actually read what they wrote down or look at their math, and they might say, like, no. So always looking at if your answer makes sense, if your symbols make sense, meaning is it a positive answer or a negative answer? Thinking about, did I use the right operation? Just always double check things and kind of looking at the big picture after you solve a problem. So now we're going to dive into the we do problems. And so we're going to look at four examples. And for each example, we're going to write a number sentence to represent the situation. We're going to solve it and then also answer it in a complete sentence. So the first question says, a bakery was ordering ingredients needed to make donuts for their Saturday morning rush. They needed 22 and 1/3 cups of flour. They only have 17 and a half cups of flour. How many cups of flour do they still need? So when we look at this, I see 22 and a half cups of flour are needed. And this is what I have is 17 and a half cups of flour. So if I'm figuring myself as the person running the bakery, I look in my cabinets and I see that I only have 17 and a half cups of flour. That's where I'm going to start at with my math problem is that I have 17 and a half cups of flour. What I know is that I need to take 22 and 1/3 cups of flour, which I know I don't have everything. So I'm gonna need all that 17 and a half cups of flour plus more. So the way I'm writing this equation is that I'm showing how what I have minus what I need. And so when we go solve this, um, let's first start with converting those mixed numbers to improper fractions. So I'm going to take my denominator, multiply it by my whole number, and then add my numerator. So 2 times 17 is 34. 34 plus 1 is 35 halves minus how many thirds? I'm going to do 3 times 22 is 66, plus 1 is 67. So now I notice that my improper fractions have do not have common denominators, so I want to make them common denominators. So I know that 6 is the least common multiple between 2 and 3. So for my first fraction, I'm going to multiply numerator and denominator by 3 to get to 6. So 2 times 3 is 6. And then 35 times 3 is 105. And I'm going to do 3 times 2 is 6. And then I'm going to do 67 times 2, which is 134. So now I have common denominators. So I'm going to look at my numerators. I have 105 minus 134. So I can also think about this as plus negative 134.6. So I'm adding two numbers with different signs, which means I'm really going to subtract. So the difference between 134 and 105 is 29. Okay, and I'm going to take the sign of the large number, which would be 134, which means it's going to be negative 29.6. And then I'm going to go ahead and convert that to a mixed number. 6 goes into 29 4 times with 5 6 left over. So my answer is a negative number. It's negative 4 and 5 6. So how I would go about writing this complete sentence is I wouldn't say that I need like negative 4 and 5 6. That word need is kind of being associated with my negative number. So I would write the bakery still needs 4 and 5 6 cups of flour. That need is kind of showing that negative sign, meaning like it's something I don't have. I don't have 4 and 5 6 a cup. That's how much more I need. So again, there's different ways that you might have approached this. A lot of you probably did 22 1/3 minus 17.5 cups of flour. I would check with your teacher, but like that would be okay too in terms of how much you need. But kind of wanted to show you a different way of thinking about what I start with, what I have, and then what I need would actually be associated with a negative number. Okay, because it's something I don't have, it's something I need to purchase still. Okay, so sorry, the first problem a little bit more challenging. A lot of ways to kind of think about it and to solve for it, but getting your brain hopefully thinking about how to kind of approach these problems. So the second problem is about temperature, and it says the temperature outside dropped 3 degrees every hour for 8 hours overnight. What was the total number of degrees the temperature dropped in 8 hours? So we're looking for total degrees, which might make us thinking of addition. In a way, it is. But if it's dropping 3 degrees every hour for 8 hours, meaning it dropped 3 degrees the first hour, and then it dropped 3 degrees again, 3 degrees again. We know that if we are repeating the same drop in degrees every hour, a more efficient way of repeated addition would be multiplication. So if I want to show this dropping 3 degrees, I'm going to show my first number as a negative 3 to show that it's dropping 3 degrees, and then it's dropping that many degrees every 8 hours. I'm going to multiply it by 8. So negative 3 times positive 8 would give me negative 24 as my answer. Now, when I go to answer the question, it's asking me, what was the total number of degrees the temperature dropped in 8 hours? I would say the temperature dropped a total of 24 degrees in 8 hours. Now, notice that I didn't say it dropped a total of negative 24 degrees in 8 hours. That dropped is showing me that my answer is negative. So I always kind of tell my students, like, there's a math answer and then there's the real world answer. So the math answer is negative 24. But my real world answer is just saying that it dropped a total of 24 degrees, where dropped is kind of being associated with that negative product. Let's look at the third problem. A scuba diver was at 4.5 meters below sea level. They descended to 7.25 meters below sea level. What was the change in their depth? So I'm off the bat seeing that we are talking about 4.5 meters below sea level. Below sea level meaning a negative. So I'm starting at negative 4.5 meters below the sea level. And then the next sentence says they descended to 7.25 meters below sea level again. So they're saying that this 7.25 should be negative because they're below sea level. And then descending is also a negative. So this is where I start. I'm descending. So I'm going to use subtraction. I'm going to subtract a negative 7.25 to show that I am descending 7.25 meters below sea level. So again, when I'm going to solve this problem, I'm going to change my mixed numbers to improper fractions. I'm going to do 2 times negative 4 plus 1. So 2 times 4 is 8 plus 1 is 9. So this is negative 9 halves. And then this is going to be 4 times 7 is 28. And this is going to be minus 29 fourths, or negative 29 fourths. When I look at this problem, I know I can rewrite any subtraction problem as an addition problem. So this actually becomes negative 9 halves plus 29 fourths. I'm going to change my first fraction to be fourths, so I have common denominators with my 29ths. So 2 times 2 gives me 4, so I'm going to do 9 times 2, which is 18. And that first fraction is negative. So now I have my two fractions with common denominators. I have negative 18 plus 29. That's going to give me positive 11 fourths, which in mixed numbers would be, not 3, would be 2 3/4. So when it says what was a change in their depth, so a lot of times when they're saying like what was the change in their depth, sometimes that change in can just be like changing in measurement is often kind of denoted with positive numbers. Like what was the change in um the distance from where they started to where they end. So a lot of times like the change in distance, you're kind of thinking about it in terms of positive. So you can say the change in their depth is 2 3/4 meters. And I would add that it's not asking you if they're above or below sea level. It's just asking what the change is. So if they went from 4.5 meters to 7.25 meter, that change in their depth is just 2 3/4 meter. If it asked you in the direction, you could say that, it was in the negative direction or in like the below, like they were getting further below sea level, but it's just asking for the change. So just saying the change in their depth is 2 3/4 meters would be like sufficient. But always check with your teacher on what they expect. Then our last example says a contractor's total change in profit was negative $31.50 over 3 projects. What was the average profit or loss per project? So this one's actually saying like their change in profit was negative $31.50. Like negatives can appear in like your books if you're running a business. Hopefully they're not. But that's when we say we're in the red, is if we are, if our books are showing that if we were having essentially not a profit, we're essentially having a loss. So if I have negative $31.50, that was my total change. And that was over 3 projects. What was the average? Average means division, profit or loss per project. So I'm going to take how much money was lost in total, and then I'm going to divide it by how many projects that contractor was working on. So again, when you're thinking about average, you're going to take that whole, meaning like the total amount of money lost, $31.50, divide it by the 3 projects. And then when you divide, you're going to get negative $10, and you're going to get negative 10.5 essentially. So in word form, or in our complete sentence answer, we would say the contractors average loss per project was, and this is where you put $10.50, where you put our units for money and actually write our decimal with that zero to show like to the nearest penny or cent. So we did a couple examples of addition, subtraction, multiplication, division. Be sure to read all these questions carefully. There's definitely different ways you could approach them. There's even different ways you might have written it, especially for the addition and subtraction sentences. So double check with your teacher. Different ways of solving for these problems are always encouraged. But here's just some examples and some ways that I solve them. So it's now time for you to work on the you do problems. There's 4 more questions to work on. So be sure to take your time to decide what the operation is, where are your positive, your negative numbers, and then making sure that you're answering it in complete sentences. Remember, there's a math answer, and then there's the actual real world complete sentence answer, where we're using words to kind of represent those positive and negative numbers. Thanks for watching and listening, and good luck.